Page 5, number 7. Yacht A moves according to x equals 4 plus t, y equals 5 minus 2t, where the distance units are in kilometers and the time units are hours. Yacht B moves according to x equals 1 plus 2t, y equals negative 8 plus t, where t is greater than 0. Find the initial position of each yacht. Okay, that should be pretty easy, right? The initial position of the yacht for yacht A is going to be 4, 5, and for yacht B it's going to be 1, negative 8. Okay, so for yacht A, 4, 5, and for yacht B, 1, negative 8. Okay, so because those are the numbers that remain when t equals 0, right? Okay. Find the velocity vector of each yacht. Okay, this is also not too hard. It'd be 1, negative 2. 2, 1. 1, negative 2. 2, 1. 2 and 1. Okay. That would be the velocity of A, velocity of B. Okay. Show the speed of each yacht is constant and state these speeds. Okay. So the speed of yacht A would be the magnitude of this vector. So the speed of A is equal to, it would be 1 squared plus 2 squared square root, so it would be square root of 5. Speed B would also be square root of 5. That would be C. D. Verify algebraically that the paths of the yacht are at right angles to each other. Okay. We can take we can find the slopes of each. So we'll say slope of A is equal to negative 2 divided by 1, right? I take the y component divided by the x component. And the slope of B is equal to 1 divided by 2. And you notice that these two are negative reciprocals. So that means that they are perpendicular. Okay, so that's it. 9. A helicopter at point A, 693, moves with constant velocity in a straight line. 10 minutes later, it is at B, 3, 10, 2.5. Distances are in kilometers. Find AB, vector AB. So to find vector AB, we're going to take vector B, which is 3, 10, 2.5. It's easier if we write bigger. 3, 10, and 2.5. And we subtract vector A, which is 6, 9, and 3. And then we get left with negative 3, 1, and negative 0.5. Okay, so this is vector AB. Okay, now B, find the helicopter speed. The helicopter speed can be found by finding the difference in the two vectors, which we just did with finding vector AB, and divide it by the time that it takes to get to the new position. Okay, so first we need to find the magnitude of that. The magnitude of that would be the square root of 3 squared plus 1 squared plus 0.5 squared. Okay, and that would be 9 plus 1, 10 plus 2.5, 10.25 square root. Okay, and that would be root 10.25, 3.2. Okay. Now we need to take the distance it went, 3.2 kilometers, and we divide it by the time it took to go 3.2 kilometers. So it would be divided by 10, and so we would get 0.32 kilometers per minute. Okay, it never said it needed it in kilometers an hour or anything, so you could just leave that. Determine the equation of the straight line path of the helicopter. So we're going to have x, y, z, and we're going to have the initial position, 6, 9, 3, and then we are going to have the velocity, which is negative 3, 1, negative 0.5. Okay. Then it says, okay, so this is C, right? D, the helicopter is traveling directly toward its helipad, which has Z coordinate 0. Find the total time taken for the helicopter to land. Okay, so basically what they're saying, it doesn't really matter what the helipad's X and Y coordinate is, because if it doesn't get to the Z coordinate of 0, it doesn't matter, okay? So let's just look at the Z coordinate, which is here, and then we'll solve to see how long it takes for Z to get to 0. So we have Z equals 3 plus negative 0.5 t. And if Z is 0, then we have 3 minus 0.5 t. So we have 0.5 t equals 3. So we have t equals 1.5. And the time, total time it takes is 1.5. Does it say what unit the time is in? It does not, I don't think. So we'll just say t equals 1.5, and that's it. Okay. 10 minutes later is that, I guess it's minutes. Okay, so t equals 1.5 minutes. Okay. 13e, shortest distance from a point, for a line to a point. Okay, so now we need to think back to the Castaway investigation where Tom Hanks or Chuck tries to get to the shipping lane, and he's going to go on the shortest path to the shipping lane. Okay, so we're going to try to figure out the shortest path from this point to that path, and of course it's going to be the perpendicular to it. So the red vector with scalar product with vector b should give you 0 because you want them to be perpendicular. A ship is close to a port at the point where the line between the ship and the port is perpendicular to its path. Perpendicular to its path. Mark the point on the drawing. So we'll mark it right there. Find the shortest distance from 3, 2 to the line with parametric equations x equals 2 plus t and y equals 3 plus 2t. 3, 2 to the line with parametric equations, etc. Okay, so we have one path, the shortest path, which is going to be from this point to one of these points, to a point on this line. Okay, so what we're going to do is we're going to find the vector, position vector for that vector. So the vector for that. So we're going to take our point. Let's call it point I don't know, S for shortest path. So we'll have point S, and then we'll subtract P from it, and that'll give us a vector. So S is going to be 2 plus T, 3 plus 2T, and we just don't know what T is yet. Okay, and then we're going to subtract point P, which is 3, 2. Okay, and that's going to give us a vector, which is the shortest path vector. 2 plus T minus 3, 3 plus 2T minus 2, which is equal to negative 1 plus T and 1 plus 2T. So this is one of the vectors. which we don't know exactly its path yet because we're going to determine it so that it's perpendicular to the path of this vector, of this line. Okay, so what is the direction of this line here? Well, we just take the velocity vector, which is 1, 2, and this is the, I don't know if you call it the slope, but it's the direction of the line, the direction vector or the velocity vector of the line. So we're just curious, okay, when is the velocity vector scalar product with this equation we just figured out equal to 0? Because if we can figure out when this is equal to 0, then its cosine is going to be 0, the angle between the two is going to be 0, and then we know it's perpendicular. Okay, so that's not so hard to do, right? So we'll take the scalar product of these two and we'll get minus 1 plus t plus 2 plus 4t equals 0. So when is this true? We got 1 plus 5t equals 0. So we got t equals negative 1/5. Okay. All right, and so now that we know that t equals negative 1/5, we can figure out what this is. So we just put in negative 1/5, which is also equal to negative 0.2. We're going to put that into t for each one. So we're going to have negative 1 minus 0.2, negative 1.2. And then we're going to have 1 plus 2 times t, which is 2 times negative 0.2 would be negative 0.4. So we have 1 minus 0.4, which is 0.6. Okay, so we have negative 1.2 and 0.6. And that is the line that should be perpendicular to the... Okay, and last one. We're going to do the same thing here. So now we have a point, and we have this line, and we want to know what is the path from this point to the line which is shortest. So again, we're going to make a, we're going to say the point, the shortest point is called S. And so we're going to say, okay, S minus R is going to be the vector that we're trying to make short as possible. So that would be 2 plus S and 3 minus S. And then that's S, and then R is minus a negative 3, negative 1. So then we're going to say the x component is going to be 2 plus 3 plus S, and this is going to be 3 plus 1 minus S. We'll simplify that. We'll have 5 plus S and 4 minus S. Okay. Okay, and then we are going to take the scalar product of this to the velocity vector of the line. Okay, the direction vector of the line. So we're going to take 5 plus S, 4 minus S, scalar product to 1, negative 1. And that's going to give me 5 plus S minus 4 plus S. Okay, and that will give me 1 plus 2S. Okay, so when is the scalar product equal to 0? When S is equal to negative 0.5, right? So S equals negative 0.5. So when S equals negative 0.5, we can substitute back in here, and then we're going to get 5 minus 0.5 and 4 minus a negative 0.5. So that gives me 4.5 and 4.5. Okay, so the vector for the line that the shortest path is 4.5, 4.5. And that's it for this page.